Okay, so let us try to understand how to draw cam profile. Now here we have considered two cases. In first case, we have considered the simple harmonic motion, and in second case, we have considered the uniform acceleration and retardation of the cam displacement. Now here we have considered only one particular stroke, that is the outstroke of the cam and follower system. So we know that the follower moves with either it can move with uniform velocity or with simple harmonic motion or with uniform acceleration and retardation, or it can have the cycloidal motion. So here we have considered the outstroke or outward motion of the follower with simple harmonic motion as shown over here. So here this AG part, it represents that we have drawn this outstroke, that is theta O, with some suitable scale, and we have divided that particular distance of AG into 6 equal parts. Then by taking this on y-axis, we are having the lift or stroke of the follower, and by taking that particular lift or stroke of the follower as a diameter, we have drawn this semicircle, and this semicircle is divided into 6 equal parts as shown over here. Now divide this outstroke, that is also in the 6 parts. So this is the first line, then second line, third, fourth, and fifth and sixth line, and project these particular points on the first line. This is on the second one, this is on the third one, this is on the fourth one, this is on the fifth one, and sixth one is already intersected, and join a smooth curve passing through all these particular points, and we'll get a simple harmonic motion. Now all this particular procedure we have already shown in animation in the next slide. Now transfer these distances. So here the first thing that is important is that here we have considered that this is a knife edge follower. So we can say that you can have the knife edge follower over here at this particular part, correct? Like this, and these are the guides which are shown over here, and the follower motion will take place along this particular path. Now we can transfer these particular distances. So this is the distance. Draw a base circle as shown over here, and divide this particular base circle into 6 equal parts as shown over here. So here we have divided this outstroke also in 6 parts. So we are dividing this base circle also in 6 parts. So this C7, C9, C11, C13, C15, and C21. Correct? These values indicates that the circle is divided into 6 equal parts. Now transfer these distances. So this is the first distance which we have transferred over here. This is the second distance which we have transferred on this second ray. This is the third distance which we have again transferred over here. Similarly, this particular distance we have transferred over here, and this distance we have transferred on this side, and this entire stroke length we have transferred from this point up to this point, and then we have joined all these points to get a smooth curve. So now let us see in the next figure how this cam profile is actually drawn. So this is the stroke or lift of the follower. Draw the semicircle. Now divide this semicircle into 6 equal parts as shown over here. Now transfer this point on our semicircle, and then join these lines. So we have transferred all these points on our semicircle as shown over here. Now we'll draw the outstroke to a certain suitable scale. So on x-axis we are having the angle, and now divide this also in 6 equal parts. Now project these points on the corresponding lines. So this is projected on the first line, this is on the next line, this is on the next line, and like this. Now draw the straight lines from the corresponding points up to this particular point which we have just now projected. And draw the smooth curve joining this particular point. Now draw the base circle. Divide this circle into 6 equal parts for the outstroke. So this is the starting point. Then transfer this point on the circle and divide the circle into 6 equal parts. So now we are dividing this circle into 6 equal parts by taking the equal arc distance. And now draw the rays passing through these particular points. And as we have seen earlier, now transfer these distances over here. So this is the first point. Then transfer the next distance over here. Then the third one, measure this distance and transfer this by using our compass. And likewise, you can mark all these particular points. And then draw a smooth curve passing through these particular points. So this is known as the cam profile. So this particular point, this particular curve that we have drawn, that is known as the cam profile. So here for the demonstration purpose, we have considered only the outstroke. Similarly, we can consider for the return stroke also, and we can draw the cam profile. Now let us see how to draw the displacement diagram in case of the uniform acceleration and retardation. So with some suitable scale, we have drawn the outstroke. Draw a line through the midpoint of this particular outstroke as shown over here and divide it into 6 equal parts: A, B, C, D, E and F. Again, divide this also in the 6 equal parts. Now join these diagonals. Now join these rays as shown over here. These rays will intersect the respective lines at this particular given points as indicated over here in this diagram. And now draw a smooth curve passing through these particular points. So in this way we can draw the outstroke motion of the follower with uniform acceleration and retardation. And now as we have seen, we can transfer these distances, these vertical distances on our base circle by dividing the base circle into 6 equal parts, and then similarly we can draw the cam profile as we have seen earlier. So in this way we can draw the outstroke motion of the follower with simple harmonic motion and with uniform acceleration and retardation, and we have seen how to draw the part of the cam profile also. Thank you very much for watching. Do subscribe to our channel.